Welcome back. This is Jeffrey, and the topic we're going to be discussing today is absolute value functions. So in this section, you'll learn to understand absolute value function, graph an absolute value function, and at last you're gonna solve an absolute value equation. First off, understanding absolute value. So absolute value function has the basic form f of x is equal to the two vertical sign with an x. So the two vertical line, we call that absolute value sign. So algebraically, for whatever the input value is, the output is a value without regard to the sign. As you can see here, whatever input you put, either positive x or negative x, you're gonna get the same output, which is f of x. So that means the absolute value function can also be defined as a piecewise function. So next up, we got graphing an absolute value function. The most significant feature of the absolute value graph is the corner point at which the graph changes direction. So for instance, we got the example here, y is equal to absolute value of x. And the changing point, or the corner point, is going to be 0, 0, because that's where the graph changes its direction, right? Next, transformation of absolute value functions. So if we look at the original function here, y is equal to absolute value of x, you can see that it looks like this, right? And that's also this equation. So if we want to shift this equation 3 units to the right, we can simply minus 3 inside the absolute value sign. Or if we want to shift the 3 units to the left, we can, instead of a negative 3, we put a positive 3. So if we x plus 3 holding inside the absolute value sign, it's going to shift it to the left. What if we want to vertically stretch it? We can simply multiply the entire thing by 2 if we want to vertically stretch it by 2. And that's going to give us this one, vertical stretch. So if we vertically stretch this function, it's going to be looking at the green function here. And at last, if we want to shift the curve, shift the function upward or downward, we can just add a unit we want it after the entire function. So if we want to move it up by 4 units, we can just plus 4. If we want to move it down by, let's say, x units, we just put minus x after the function. Then we got solving the absolute value equation. So to solve an absolute value equation such as 8 is equal to absolute value of 2x minus 6, we notice that absolute value will be equal to 8 if the quantity inside the absolute value is positive or negative 8. This leads us to two different equations we can solve independently. So first we got 2x is equal to positive 8. And then we got 2x minus 6 is equal to positive 8. Or 2x minus 6 is equal to negative 8. Which leads us to different answers. So if x is equal to 7 and x is equal to negative 1. So an absolute value equation is an equation in which the unknown variable appears in absolute value bars. For example, absolute value of x is equal to 4. Absolute value of 2x minus 1 is equal to 3. Or absolute value of 5x plus 2 whole thing minus 4 is equal to 9. So just know that. That's how we usually solve the equation. So let's do some practice question. So I want you to look at this graph and then write an equation for this function. I'll give you guys 30 seconds starting from now. So you should got something similar to this, right? So f of x is gonna be equal to 2 times the absolute value of x minus 3 minus 2, whole thing minus 2. So we minus 2 because we want to shift it downward by 2 units, right? And then we vertically stretch it by 2 as well. So it's gonna be looking more narrow. and then we shift it to the right by 3 units. So it's going to be -3. Just know that. Okay, moving on to the next question. Finding the zeros of an absolute value function. For the function f of x is equal to absolute value of 4x plus 1 whole thing at 7. Find the values of x such that f of x is equal to 0. I'll give you guys a minute to work on this. Start from now. Okay, so here's the answer. So we first move the -7 to the other side. So we got 7 is equal to absolute value of 4x plus 1. And then we got our two independent functions. The first one is positive 7 is equal to 4x plus 1. And then we also got -7 because this can also be -7. But since it's inside the absolute value bar, we have to consider that as well. So -7 is equal to 4x plus 1. Then we minus 1 on both sides, we get 6 is equal to 4x. And then we minus 1 on both sides, so we got -8 is equal to 4x. And at last we got x is equal to 1.5 and x is equal to -2. And that's it for our lesson for today. Thank you.